Okay, find a point estimate for a proportion. A proportion is how much something is out of the total. So 109 developed a reaction out of 4179, and we want a 99% confidence interval. Okay. So we're going to get more help. StatCrunch. Stat, proportion stats, one sample, with summary because they just gave us the final answers. We don't have the list of people. So there were 109 out of 4179. We want a confidence interval at 99%. Okay, so our sample proportion is 0.026. Our lower limit is 0.01. Okay, that 7 makes that 9 go up to 20. 0.020 and 0.032. Okay, so our point estimate is 0.026. Our lower limit, 0.020. Upper limit, 0.032. Okay, the give or take is the difference between upper limit and the estimate. Okay, the estimate is the exact middle in between the lower and the upper. Okay, so we can just take the upper limit, subtract the point estimate, and that equals 0.006. Okay, now let's go back. So the point estimate, 0.026. Our error is 0.006. Our interval, 0.020 to 0.032. Okay. One has 99% confidence that the sample proportion is equal to the population. Oops, sorry, I didn't read the full thing. One has 99% confidence that the interval from the lower bound to the upper bound contains the true value. Okay. All right, next it says a study of 380 and 323 were girls. 323 out of 380. Okay, so this is a clinical trial deciding if a couple can choose the gender of their child by a method. Okay, we're going to round to 3 decimal places and find a 99% interval. Okay, so let me see if I can find my StatCrunch. Now we can hit Options, Edit, and just change those numbers. 323 out of 380. And what did it say? 99%, so we're going to stick with that. Okay, now this just said the interval, so our lower limit is 0.020. .803. Our upper limit is .897. .803, .897. Okay, now what would you expect? What percent would be girls? You would expect about 50% of babies to be girls and about 50% to be boys. But look at this. This is .803, which is 80% up to 90%. Okay, that's an extreme amount of girls. Okay, does the method appear to be effective? Yes, that is significantly different than half. Okay, 80 to 90% is the estimate of girls. So that is significantly different from an expected value of half of the babies to be girls. Okay. All right, now we're going to do something similar except with green peas and yellow peas. Okay, now it gave us a little bit different. It gave us green and yellow, but it didn't give us the total. So we need to add 449 plus 160 equals 609 total. Okay. Construct a 90% confidence interval to estimate the percentage of yellow. Okay, so yellow is 160 out of 609 total. We want a 90% interval. And we want to round to 3 places. Okay, StatCrunch, we're just going to edit this. 160 were yellow out of 609 total. A 90%, so this is going to change to 0.9. Okay, our lower limit is 0.233. And our upper limit is 0.292. Okay, 0.233, 0.292. Okay. Do you expect the results to be different than 25%? Okay. 25% is 0.25. See how 0.25 falls in that range? 0.233, 0.292. 0.25 falls in that range. So, no, the confidence interval includes 0.25, so the true percentage could easily be 25%. Okay, we're saying 23% to 29% is our range, so it could be 25%. Okay, now we were doing percentages there. Now we're going to estimate a mean, which is an average. Okay, a data set includes 106, so N is 106, mean 98.9, standard deviation of 0.63, 99% interval, and 3 decimals. Okay, I'm writing all this down for when I go to StatCrunch. Okay, now I need to close that because we're no longer doing proportions. So we're going to go to Stat. we're going to go to T-stats, one sample. Sorry, Z-stats, one sample with summary. Okay, the sample mean is 98.9. The standard deviation is 0.63. And the sample size is 106. Confidence 99. Okay, so we have 98.742 to 99.058. 742 and 058. Oh, sorry, I was right with the first time with the T-stats. Okay, it didn't, I thought it said, sorry, I'm opening up too many things. It said it didn't say it was normally distributed. Okay, that's why we need to use the T-stats.